But for 1.6 problem number 11, let that focus in there. It's taking its sweet time. Not quite sure what's going on with that. Maybe because it's on an angle, I don't know. There it goes. Yes. All right. So they want us. They've given us y is equal to 3 cosecant of 3x plus pi. Is it minus 2 or plus 2? Minus 2. And they ask us a bunch of questions, right? They want to know what is the period. Well, now the period, so let's talk about this. This is the amplitude, right? The period is going to be calculated by saying 2 pi over 3, sort of, right? That's how you find that. Where did I get the 3 from? The 3 just comes from this. It's 2 pi divided by whatever this thingy is, right? There's a vertical stretch. Does it ask, or not a vertical, but a horizontal stretch? Does it ask for that? No. And then it asks for the domain and range of the function. And then it wants us to draw the function. A lot of work, a lot of work. I don't know if we'll even be able to finish this. This is going to be the vertical shift. All right. So we've done part A. Part A says, what is the period? Okay, so I'm going to write over here, A wanted the period, all right, and the period we found was 2 pi over 3. That was easy, okay? So now the next thing, B wants the domain. So we want the domain, and I think C is the range. Maybe it's not A, B, C. I know these are two of the things that they're asking for. No, that's right. The domain, the range, and then D, we have to draw the graph. Bless you. So now, the domain, here's what we need to think of. Okay? Think. All right? Sine, think of this. Y equals cosecant of some stuff is equal to 1 over sine of that same stuff, right? Is that right? Yeah. Does that make sense to you guys? So what are the restrictions on domains? Restrictions on domains are two things. Can't take the square root of a negative number. We don't have any square roots here. And we can't what? Can't have 0 in the denominator, so sine of the stuff cannot equal 0. So what is the stuff? This. So sine of 3x plus pi cannot equal 0. That's a big issue. It's a big issue. Okay? Because when that happens, this whole term right here is undefined. It's not a number. It doesn't exist. It's not there. We can multiply undefined by 3. Oh, actually we can't, so that's a problem. And we can subtract 2 from undefined. Oh, no, wait, that's a problem too. So our domain is an issue here. So when does sine equal 0? Well, if you remember the function of sine, if this is my y and this is my x value, sine kind of does one of these wavy deals like this, right? And it equals zeros here. Now, we know that it has a period of 2 pi. So that means that it crosses the 0 here at 1 pi, and that means it crosses at 0. And then it crosses again here at 3 pi. And it does the same thing in the other direction at negative pi and negative 2 pi and so on and so forth. what does that mean? That means that here we have the point pi comma 0. Here we have the point 2 pi comma 0. So the y values equal 0 every multiple of pi, right? So what we could say, and this is, we're just going to say sine of some stuff equals 0 when stuff equals k times pi, where k is a integer, right? So if I plug in -1, -2, -3, 0, 1, 2, 3, 4, if I make all those, in other words, k is an integer, right? K is anywhere from -1 to positive, it's an integer. But we don't want that. So what we want is the stuff not to equal k pi. In other words, 3x plus pi cannot equal k times pi. And by the way, we're just doing algebra, right? I'm going to try to finish up. If I solve this whole thing, what I do is I want to solve for x, because that's what our domain is. Our domain focuses on the x. So if I subtract pi from both sides, I get k pi minus pi is equal to 3x. Divide everything by 3, and I get, if I factor out the pi times the quantity k minus 1 all over 3. But k minus 1 is still an integer, isn't it? Factor out the pi. So if I change this, if I factor out a pi, I get k minus 1, right? Okay. Well, k minus 1 is still an integer, so I could think of this as like being k pi over 3, right? Because any integer minus 1 is still an integer. So to simplify my formula, I'm going to say that x cannot equal k pi over 3. So my domain is all reals, but x cannot equal k times pi over 3. Okay? And then we could probably pick up and do the range tomorrow. The bell's going to ring in a second.